Here are a few examples of solving polynomial equations, which is going to use our ability to factor polynomials and our knowledge of the zero product property from factoring quadratics. So these first two equations are already in factored form. And if we remember, solving an equation means to find the value of x that makes the equation true, or the left side equal the right side. So if it's already in factored form, that means that if any of these brackets are equal to 0, the left side is equal to 0, which is equal to the right side. So I can say that x is equal to 3, x is equal to minus 2, or x is equal to minus 1. Similarly, on this example B, I can say that x could be 0, x could be equal to minus 3, or x could be equal to positive 2. So again, I'm just taking a bracket, setting it equal to 0, and then solving for x. Sometimes an equation is not in factored form, and in order to be able to use the zero product property, an equation must be equal to 0, and it has to be in factored form. So if it was a quadratic, we could factor that using multiplying to the last term, adding to the middle term. Here, now we have to use the factor theorem and polynomial division. So let's check. We're going to define our related function. So let's let f of x equal the left-hand side of our equation, and then we're going to figure out what numbers are a factor. So let's try f at 1. I'm going to get 4 minus 12 minus 1 plus 3. That is not equal to 0. So let's try f at minus 1. I'm going to get minus 4 minus 12 plus 1 plus 3, which is not equal to 0. Okay, 1 and minus 1 aren't factors. Let's try our other whole number factor. I'm going to try let's try f at positive 3. So this is going to give me 3 cubed is 27. So 4 times 27 minus 12 times 9 minus 3 plus 3. So let's see, 4 times 27 minus 12 times 9. Those ones are equal to 0. That is equal to 0. That means that x minus 3 is a factor of the polynomial. And what that means is that on this side, I'm going to say that I can write this as x minus 3 times something equals 0. To get that something, I'm going to use synthetic division. And I'm going to put my coefficients across. I've got 4 minus 12 minus 1 and 3. Bring the 4 down. 3 times 4 is 12. Add those together, I get 0. 3 times 0 is 0. Add them together, I get 1. Minus 3 and 0, which confirms that I do have the correct factor. This is my constant term, my x term, and my x squared term. So this is 4x squared minus 1. So that means that this is my remaining factor. This is the same thing we did with polynomial functions, except now the right-hand side is equal to 0. So now my two equations, I can say that x minus 3 is equal to 0, or I can say that 4x minus 1 is equal to 0. So this first one gives me x could equal 3. The second one gives me that x squared is equal to a quarter, which means that x is also equal to plus or minus 1/2. So the second one that we're going to do here is, looks like it could be more complicated, okay, because it has some not prime numbers, but it also doesn't have a number in front of the x cubed. So let's define our related polynomial. So we've got f of x equals x cubed plus 9x squared plus 13x plus 5, and we're going to find a factor. So I'm going to start with factors of 1 or 5. So let's start with 1. So I've got 1 plus 9 plus 13 plus 5. That's definitely not equal to 0 because they're all positive. F at minus 1 will give me minus 1 plus 9 minus 13 plus 5, which is equal to 0. So that means that x plus 1 is a factor. And so that means I know that my original cubic function I can write as x plus 1 times something equals 0. In order to find my function, that's something, I am going to factor out x plus 1 from my polynomial. So I put my coefficients across, and I'm going to apply synthetic division. Which gets me 0, which confirms that I had the right factor. Then I have x squared plus 8x plus 5 as my result, or as my quotient when I perform that division. That is the something that I put in here. I've got x squared plus 8x plus 5. Now I'm going to take a look at this. I'm looking for two numbers that multiply to 5 and add to 8. That's not possible. So that means that I need to use the quadratic formula. So I know that either x plus 1 equals 0. So that's one possible solution. Or I know that x is equal to negative b plus or minus a square root b squared minus 4ac all over 2a. You can look up the quadratic formula if you don't remember it at this point. When I simplify, you can do this in fewer steps. I like to do the part underneath the square root, and then you can leave it as this exact value, or you could further simplify to the decimal value by continuing to evaluate. So there are still 3 solutions, 1, 2, 3. It's just 2 of them happen to be decimal values, so you need to use the quadratic formula to solve the equation.